This ship costs more than the annual defense budget of many countries. It is the largest warship ever built, the most technologically advanced aircraft carrier ever launched, and one of the most controversial military projects of the modern era. The United States Navy has begun testing the USS Gerald R. Ford, the lead ship of a new class of aircraft carriers designed to shape American naval power for decades to come. What we are seeing in this video is not just another sea trial. It is the culmination of more than 20 years of planning, engineering, political debate, and enormous financial investment. The Gerald R. Ford class represents a fundamental shift in how the United States views aircraft carriers and their role in modern warfare. Unlike earlier carriers, this ship was not designed simply to carry aircraft. It was designed to serve as a floating command center, an energy hub, and a platform for technologies that did not even exist when construction first began. For more than half a century, American aircraft carriers have been symbols of global power. From the Cold War to modern conflicts, they have allowed the United States to project air power anywhere in the world without relying on foreign bases. The Ford class was created to preserve that capability in an era where threats are becoming faster, more precise, and more technologically complex. The sheer scale of the ship is difficult to fully appreciate. Measuring over 330 meters in length and displacing more than 100,000 tons, the USS Gerald R. Ford is effectively a floating city. Thousands of sailors live and work aboard the carrier, maintaining a constant cycle of flight operations, maintenance, and navigation. On its deck, the ship can support nearly 90 aircraft. These include advanced fighter jets, electronic warfare aircraft, airborne early warning planes, helicopters, and in the future, unmanned aerial vehicles. This air wing gives the carrier the ability to conduct sustained combat operations far from home, without needing immediate logistical support. One of the most visible changes compared to older carriers is the redesigned flight deck. The layout was carefully optimized to reduce bottlenecks and improve the flow of aircraft. By repositioning elevators and rearranging deck equipment, engineers aimed to increase the number of aircraft launches and recoveries per day. In combat, this translates directly into increased striking power. At the heart of the Ford class lies one of its most ambitious technologies, the electromagnetic aircraft launch system, known as EMALS. For decades, aircraft carriers relied on steam catapults to launch aircraft. While effective, those systems were mechanically complex, physically demanding on aircraft, and limited in flexibility. EMALS replaces steam with electromagnetic force. Aircraft are accelerated smoothly and precisely using powerful electric motors. This reduces stress on airframes, extends aircraft lifespan, and allows the carrier to launch a wider variety of aircraft, including lighter drones and future unmanned platforms. However, EMALS has also been one of the program's greatest challenges. During early testing, the system suffered from reliability issues. Components failed more often than expected, forcing engineers to redesign parts while the ship was already operational. Each setback delayed deployment and increased costs, fueling criticism from lawmakers and defense analysts. Landing aircraft on a carrier deck is just as complex as launching them. The Gerald R. Ford class introduced a new advanced arresting gear system to replace traditional hydraulic arresting wires. This system was designed to handle a broader range of aircraft weights and improve safety. Like EMALS, it faced early technical problems that required extensive testing and modification. Powering all of this technology are two next-generation nuclear reactors. These reactors generate significantly more electrical power than those used on previous carriers. This massive energy reserve does more than propel the ship through the ocean. It supplies electricity to radar systems, communications networks, electronic warfare equipment, and advanced sensors. The Navy deliberately designed the Ford class with excess power capacity. The goal was to future-proof the ship, allowing it to integrate new technologies over its lifespan. Directed energy weapons, such as high-powered lasers, are often mentioned as potential additions. While not yet deployed, the ship's power systems are already capable of supporting them. Automation is another defining feature of the Gerald R. Ford. Compared to earlier carriers, the ship requires hundreds fewer sailors to operate effectively. Automated systems monitor equipment health, manage logistics, and assist with aircraft handling. Over decades of service, this reduction in crew size is expected to save billions of dollars. Despite these advancements, the Ford class has been the subject of intense debate. Critics argue that aircraft carriers themselves are becoming increasingly vulnerable. Advances in anti-ship missiles, long-range surveillance, and hypersonic weapons have raised concerns about whether large carriers can survive in high-intensity conflicts against capable adversaries. Supporters of the program respond that aircraft carriers were never meant to operate alone. A carrier strike group includes destroyers, cruisers, submarines, and aircraft that work together to detect and neutralize threats. In this layered defense system, the carrier serves as the central node rather than an isolated target. The video shows extensive sea trials where systems are tested under real-world conditions. Launches and recoveries are repeated again and again, not for demonstration, but to identify weaknesses. Every malfunction, every delay, and every unexpected behavior is carefully documented and analyzed. These trials are not about perfection. They are about reliability. In wartime, even minor system failures can have serious consequences. The Navy's goal is to ensure that the Gerald R. Ford can sustain high-tempo operations over extended periods without critical breakdowns. Beyond its technical role, the Ford class also carries political and strategic weight. Building and operating aircraft carriers is a signal of national capability. Very few countries possess the industrial base, technological expertise, and financial resources required to construct ships of this scale. For allies, the presence of a U.S. carrier can represent security and reassurance. For rivals, it serves as a reminder of American reach. In this sense, the Gerald R. Ford is as much a diplomatic tool as it is a military one. At the same time, the cost of the program cannot be ignored. With a price tag exceeding $13 billion for the lead ship alone, the Ford class has become a focal point in debates about defense spending priorities. Every delay and technical issue amplifies these concerns. The Navy argues that long-term savings from automation, improved efficiency, and extended service life will offset the initial investment. Whether those projections will hold true remains an open question that only decades of operation can answer. As technology continues to evolve, the role of aircraft carriers will likely change as well. Unmanned aircraft, artificial intelligence, and networked warfare are already reshaping how military power is applied. The Gerald R. Ford was designed with these trends in mind, even if its full potential has yet to be realized. In the end, the USS Gerald R. Ford represents a calculated risk. It is an attempt to leap forward rather than take incremental steps. History shows that such leaps often come with setbacks, but they can also redefine entire eras of military capability. This ship may ultimately be remembered as the foundation of a new generation of naval warfare. Or it may be seen as an expensive experiment that revealed the limits of technological ambition. The answer will not come from trials alone. It will come from how this carrier performs when it matters most, in a world where power, technology, and uncertainty continue to collide.